is we have some people that were surveyed, students that were surveyed. They were asked two questions, male or female, and are you left-handed or right-handed? Okay? And so we're just going to kind of show how this table gets organized and how it all kind of sets up. And then we're going to use these tables in kind of some different ways today. We'll eventually use it to answer probability questions like we've been doing. But we have to be able to set the table up correctly. If we don't set the table up correctly, then that kind of throws off everything from then on. Okay? This one is pretty straightforward. If I wanted to figure out how many males answered this survey, I would just add across, right? I would just add 7 plus 48, and that would give me 55 males. And then the same for females. I would just add straight across. 9 plus 86 would give me 95 females. Then I can also add down. Adding down is the other question that is being asked. So you have left-handed people, which were 16 of them. And then adding straight down, 48 plus 180, or 48 plus 86 is 134. Okay? And what should happen, if all of my numbers are correct, is when I add these two together, and when I add these two together, it should give me the same total. Because it's two different questions that we're combining together. And if we add this all together, we should get 150. Okay? But that's kind of a way to check yourself, is to make sure that these two add up and these two add up to be the same thing. If they don't, then I got to go back and check my addition and subtraction. Okay, joint frequencies is the individual data entries. Okay, so like for instance here, this would be 7 males were left-handed, right? So that's an individual event that's happening, or based on the survey, the question that was asked. The marginal frequencies are the numbers that are over here. That's the sum of each of the different categories. So it's the sum of the rows, it's the sum of the columns. Whatever question was being asked in that survey, that gives me the sum total of each of those questions. So I could figure out then how many people were right-handed, how many people were males, and I could answer a lot of different questions about the totals from that table. Okay, number 2 is set up a little bit differently, because instead of just giving us the data from who checked what box or whatever, then here we're kind of working backwards. I had 136 people total that said yes, they checked their bag. 50 of them said yes, this is my final destination. So to figure out what this number is here, there's 2 ways to figure it out. I could either take 136 minus 50, and that should give me this, or I could take 134 minus 48, and that would give me this. Both of those should work out the same way. So we just have to kind of work backwards to figure out what fits in that box right there. So if I take 136 minus 50, then that should give me 86. Okay, the rest of them are just totals, right? Same thing we did on the first one. 16 and 48 make 64. 50 and 16 make 66. And if I add these two together, or if I add these two together, it should give me the same total, okay? And probably would always be a good idea to double check both of those, because if this one gives me 200, but this one gives me 190, then I've done something wrong, right? So we want to double check and make sure that those two sums are both the same. And so that would be always a way to kind of check yourself. Okay, the next thing that we're going to do is we're going to talk about the joint relative frequencies, okay? So this is different than the joint frequency that we talked about at the top. Whenever it uses the word relative, we're going to put our information in here as some type of fraction or decimal, okay? It's basically a percentage. What percentage of the people answered this question this way? And so in this case, we know we're going to use the same data that we had. So we have a total of 200 people. Okay, that's the first thing that we got to identify. We have a total of 200 people that were surveyed. To get each one of these, we're going to take the number that's in the box divided by the total. Okay? And I'm not going to write the fraction for each one of these. I know normally that we write this as a fraction, but for today when we do these relative frequencies, we are going to write them as decimals. So if I take 50 divided by 200, that's really a fourth of the people, 0.25. Okay, then I'm going to take 86 divided by 200, and we're just going to keep going throughout this. Okay, and I'm not going to write the actual fraction in there, but just know we're using this data to answer this question here. So these two boxes go together. Okay, and there's really two ways that you can come up with this right here. Once I have these two decimals, I could add these two decimals together to get this, kind of like we did on the previous boxes. Or I can also take 136 and divide it by 200. Either way, it should give me 0.68. Okay, so there's a couple of different ways that I can get there. It doesn't matter which way you go about it. Probably the easiest way is if I already have numbers in all of these slots, then I can just divide all the way through. And so we're going to continue 16 divided by 200, 48 divided by 200, 64 divided by 200, okay. And what should always happen when we do this with the relative frequencies is this bottom right-hand box should always be 1. And that represents 100% of the population, or 100% of the people that were surveyed in this category. As you add straight down, these two percentages together should add up to be this. These two should add up to be this. If it's bigger or smaller than 1, that means I'm missing some data, right? And so it should add up to be exactly 1 every time when we do these relative frequencies. Also, just to make sure your numbers all make sense, these two should add up to be this, these should add up to be this. If you want to double check all of your math, then the addition is still going to hold true like we did on the previous couple of boxes. Okay, so really kind of filling out the boxes isn't that big a deal. The math's not real hard. We just want to double check our math to make sure that we're doing things the right way. Okay, now we're going to use the two-way tables to answer questions. Okay, the first thing we need to know, and there's going to be a lot of different types of probability. Some of the probability is just going to be a basic probability like we did before the break, where we're finding probability based on the entire category of people. Or we're also going to see some conditional probability like we saw yesterday, where we're given a specific condition. And so we're looking at a smaller group of people. We're not going to do that unless we see that slash. Like we see this slash right here, that means conditional probability. So that changes everything. So you got to be really careful about what type of probability that we're doing. But if I do a problem like part A, then I'm using the total of the entire group of students that we're looking at. Here we're asking students in band if they rented or owned their instrument, and do they practice at home. So they're asking them two questions. Okay, and that's what's being done here. Yes, they practice. No, they don't. They rent or they own. Those are the two different things that are being asked here. Now, if I wanted to figure out how many total people we had, what would I do to get that? Well, we could basically just fill it out like what we did on the last couple of problems. And you may not need each specific category, but I'm going to go ahead and fill out each category, because there are going to be some times where maybe I'm going to use the whole group of people that own their instrument, or maybe all the people that practice their instrument. So if we add those together, how many total people do we have? 125. So there's 125 students that were surveyed in the band. Okay, what is the probability that a student does not practice? So what I was trying to tell you earlier is we're going to use the entire group because we don't have any specific condition that was given to us. So we're looking at all students in the band. Out of the 125 students that we have, how many of them do not practice? 43. Okay. And so here, because we're not doing relative frequency, we'll just leave it as a fraction. Okay, we'll just leave it as 43 over 125. The only time we really have to do that relative frequency is if we're filling out that table as a relative frequency. I still would probably prefer you writing your answer as a fraction here. Okay, what's the probability that a student practices and rents? And means both. They're practicing and they're renting their instrument. Okay, so how many students practice and also rent? 62. Okay, 62. So that is one specific group. This group right here. It doesn't say practice or rent. It says practice and rent. They have to do both. If it said practice or rent, then I would add up all the people that practice and I would add up all the people that rent. But that's a big difference there. Okay, for part C, now we see the conditional probability like we did yesterday. And remember, when we do the conditional probability, we always do the bottom number first. So in this case, we're going to identify how many people own their instrument. And this is where adding up the columns or rows I think is helpful. So as I look across here, I see how many people own, and we have a total of 35 students that own their instrument. So now 35 is my bottom number. We're not looking at the whole group of students. We're only looking at students that own their instrument, okay? And out of those 35, how many do not practice? So we're only looking at this group right here. And do not practice would be 15 of them. So 15 out of the 35 do not practice. Okay? You've got to be really careful about the conditional probability. And then if we can reduce it, we always reduce it. Take 5 out of each one of those, and we're left with 3 over 7. Okay? Part D. What's the probability that a student rents given that they practice? So we got to do the bottom number here first. What would be my bottom number? How much? 82. That's how many people practice. 82. We go to practices, we look at this column. 82 is the total for that column. That's why it's good to go ahead and just add those up. Out of those 82, we're only looking at those 82 students. How many of those 82 students also rent their instrument? 62. So 62 out of 82. 2 goes out of both of those. And we get 31 out of 41. Okay, I'm going to give you a couple of minutes. Try to do number 5. All 4 parts to number 5. Very, very similar to the one we did just a second ago. This one has a third row to it, but still is done the same way. So try to answer these 4 questions, and then we'll go through them. Well, I want you to try it on your own a little bit first. And you can just leave your answer as fractions again like we did on the last one. All right, first thing we should do, and I went ahead and just did it, and you may not need all of these numbers, so some people say, well, do I really need to do that? Maybe not, right? We're probably not going to use all of those numbers, but I like to do it just so we have them, we're ready to go, and we can just answer the questions, and if we need one of those categories, we can do that, okay? But you're probably not going to need all of those numbers. Probability of Class B, am I working on like a given condition here? Or am I looking at the whole group of people? The whole group, right? Because there is no slash here. So when it just says, what's the probability of picking somebody from Class B, then I'm looking at the whole group of students, and the whole group of students, we know there's 80 of them, okay? How many students are in Class B? 32, okay? So we would just do 32 out of 80. Reduce it if you can, which we can. In this case, and this is why I think probably doing it in your calculator will reduce it for you, but we might see that 2 goes into it, 4 goes into it, 8 goes into it, but 16 is actually the GCF. It's the greatest common factor of both of those. So I can actually take 16 out of both of these, and that would leave me 2 over 5. So just make sure your fraction is fully reduced, okay? If you take out 2, or if you take out 4, or if you take out 8, it wouldn't be completely reduced. So you'd have to keep reducing. And you may not recognize that right from the start. I don't expect you to recognize that 16 goes into both of those immediately. But just know if it's reduced or not. Okay, for part B. This one I think is a little bit tricky. First of all, what's our bottom number going to be here? That's the first thing we always want to decide. What are we going to put on bottom? What do you think? 80. Yeah, because is there a slash here where we're given a certain group that we're going to narrow the focus? No, we're looking at the whole group of people, okay? The only time we're going to do a smaller group of people is if we see this little slash right here. We're going to say, look at this based on this group of people. So they're limiting our group. In this case, we're not limiting the group at all. So our bottom number is still going to stay 80. We're looking at the entire group, okay? But where this, I think, gets a little bit tricky, okay? Class C, we'll start with Class C. Class C would be these two groups right here, which is 26 people, okay? Or they can also come from the people that passed, okay? And the people that passed is this group, okay? And why I say this is a little bit tricky, we don't want to count the 21 twice. We've already counted the 21 when I added up the 26 here. So we had 26 people that were in Class C, and then we're going to add 19 and 24 to that because they also passed. So all they have to do is fit into this category or this category, okay? So that's whenever it's or, there's a lot more possibilities. So basically it's everybody except for these 11 people. These are the 11 people that don't fit either one of those categories. And so that gives me 69 out of 80, which does not reduce, so that would be my answer, okay? That's different. The one we did up above was and. If I said Class C and passed, then that would be these 21 people right here. Those are the people that did both. They were in Class C and they passed. So 21 is a lot different than 69, right? Those two numbers are quite a bit different. And so one word changed everything, and versus or. And my answer was quite a bit different. Okay, now C and D, we're looking at a specific group, okay? And so what we always say is always do the group, the big group first. So Class A, how many people were in Class A? 22. So 22 is now my bottom number. We're not looking at all 80 students. We're just looking at those 22 students. And out of those 22 students, how many did not pass? 3. That would be it. Okay. So once again, kind of like we said yesterday, we're going to limit our focus. We're kind of narrowing it down a little bit. Okay, and then part D, what's the probability that someone in Class B, given that they passed? So we're going to put the bottom number as the number of people that passed. So we're going to go over here to pass. We're going to add this whole column up, 19, 24, 21. That's why it's nice to already have that number there. 64 is my total. Out of those 64, we're just looking at that group of 64 students. How many of them were in Class B? So we're looking at these three numbers here. Class B would only be these 24 students. So it would be 24 over 64. Okay. And then just be careful when you reduce. 2 goes into both, 4 goes into both. 8 is the biggest thing that goes into both. So it would reduce down to be 3 over 8. But like I said, most of your calculators, if you put in 24 fraction 64, it'll reduce it for you. So that's kind of a nice feature that some of your calculators would do for you. Okay, any questions on those? You guys do okay on those? Kind of makes sense? All right, the last thing that we're going to do here is we've got another survey that we did here. A restaurant is going to ask people if they like chocolate, strawberry, or vanilla ice cream. And do you like it in a cup or a cone? Okay, those are the two questions that you're going to answer. So this tells us our survey results over here. So let's go ahead and total these up. So how many people were in this survey? 200. Okay. Sometimes it tells us that, sometimes it doesn't. It did tell us in the problem here that there were 200 people. So my data better add up to be that, right? If not, we're missing some answers or we added wrong. Okay. The key here is it says we're looking for the relative frequencies of each one. Okay? So to get the relative frequencies, everything in this table here is going to be a decimal. So we're going to take all of these numbers here and divide it by the total, which is 200. So we're going to divide all those numbers by 200. So we're going to do 42 divided by 200, which is 0.21. And we just got to go through and we got to divide each one. So the math there is, like I said, it's not real hard, just a matter of more time consuming than anything else. And this especially is where you want to check your math. Okay, we talked about it on the previous page. We want to make sure that these two add up to be 1, and we want to make sure that these three things add up to be 1. If any of my math is wrong, that's going to throw off my probability. Okay, so double check your answers. If you don't go back and double check, there's a good chance that you might make a mistake. And then if you make a mistake here, you're going to make a mistake when you answer your probability questions. Okay, so that's why I think it's essential that you check your answers, check your work. Make sure these numbers are adding up to be 1. If it doesn't, then where'd I go wrong? Maybe you did some division wrong somewhere. Okay, so now probability of picking a cone. Now here's the nice thing about relative frequencies is we don't have to do 112 over 200 because I've already done that. So we have a 56% chance of someone picking a cone based on our data. Okay, so I've already done the math for that. And so on this case, this would be better to write our answer as a decimal because we already have the relative frequencies. So if you have a relative frequency table here, then we probably want to write our answer as a decimal or a percent. Okay, cup or chocolate. Cup would be these right here, okay? Or chocolate means we need to add up, this right here. So we're gonna add up all of the cups plus the additional chocolate number that we have right here, okay? We can't just add up this and this, because that means we would be counting this number twice. We don't want to count this number twice. If you get a number that's bigger than 1, that's telling you something's wrong. Okay, look at your answer when you're done and does it make sense? So if I add 0.44 plus 0.485, what do I get? Seems too big. Yeah. Did you add this one in twice? Yeah. So we just got to be careful. That one that doubles up, we will only want to count it once. You could either write your answer as 0.715 or you could say 71.5%. The percentage probably means a little bit more to us because that's the percent of people that chose a cup or chocolate ice cream. Okay, now we're looking at the conditional probability. What's the probability that someone likes strawberry given that they like a cone? So we're going to look at the total for cone, which is 0.56. And out of those 0.56, only looking at this column here, how many of them like strawberry? And that would be 0.11. So to get my answer here, I would divide those two. I would take 0.11 divided by 0.56. And what's that give me?
0.1964.
Okay. And so that means about 19.6%. Okay. And I'm okay with either answer. Okay. Both of those answers mean the same thing. Percentage maybe means a little bit more. Okay, last one. Probability that someone chose cup given that they did not like vanilla. So what was the percent of people or the decimal of people that did not like vanilla? What numbers do I need here? What percent of people liked vanilla? 0.265. It's this group right here. This is the group of people that like vanilla, right? These people like strawberry, these people like chocolate. So these are the two groups of people that do not like vanilla. They chose chocolate or strawberry. So we're going to add these two numbers together. So 0.485 plus 0.25. So that would be 0.735. That's my bottom number, okay? And out of that group, how many of them chose a cup? Okay, so here we're looking at these two groups right here, right? These chose a cup and these chose a cup, okay? We're only looking at these two rows right now. We're not looking at the people that chose vanilla because we already eliminated vanilla. So we're only looking at this row and this row, and these are the two groups that chose a cup out of that. So that would be 0.35 out of 0.735. Okay, we got two numbers that would fit that because both of those people liked cup and they did not like vanilla. Okay, if we divide those two now, we get about 47.6%. Okay, questions on any of that? Okay, the one thing I will continue to say is just take your time. Okay, reading these questions, taking your time, breaking it down into smaller parts is a really big deal. Okay, and that's why I've stressed that so much, because if you do that, I think you're going to be fine. Okay, these can be a little bit tricky at times, but as long as you take your time, read it carefully, you'll be all right. All right, those are the 5 questions we got for today on your homework page. This is homework 6. out of your packet, just those 5 questions. Like I told you yesterday, I will post answers